Anyway, good afternoon, everyone, and welcome to the virtual learning course, Getting Control of Your Site, a discussion on pavement maintenance, repairs, and planning. My name is Sarah Snaley, and I'm with Timmons Group, and I will be moderating today's session. Just a few housekeeping items before we get started. This program will be provided via both audio and web conference, and will last approximately 60 minutes, including Q&A. If you have questions at any point during today's presentation, you may submit them via the Q&A button at the bottom of your screen. We're going to get to them at the end of the presentation, so feel free to send them at any point in time and we will get them covered. Also, please note that this presentation is worth 1 AIA HSW credit. So all certificates will be, certificates of completion will be sent out via email following the presentation. And now it is my pleasure to introduce our speaker for today, Frank Slinsky with Timmons Group. Frank, take it away.
Okay, thanks, Sarah. Welcome, everybody, and thanks for joining this webinar. As Sarah mentioned, I'm Frank Slinsky. I'm a civil engineer, and over the past 24 years, I've been working on public site development projects, road projects, and highway projects, mostly focusing on site development. Very hands-on. I work everything from design through construction, do construction administration, QA, QC, involved with the testing, warranty inspections, and have done numerous pavement evaluations and maintenance plans for clients. So I thought I'd share some knowledge here and hope you enjoy the webinar. So I'm going to get started. We have quite a few slides, so appreciate you all attending. So asphalt pavement maintenance, repairs, and planning, getting control of your site. So our discussion today will include asphalt pavement overview, asphalt service life, pavement life cycle phases, typical pavement failures, maintenance and repair categories, pavement evaluations and planning, and question and answer opportunities. So what is asphalt pavement? An overview. Asphalt is by far the most widely used paving material in the United States. Asphalt pavement is known for its stability, durability, flexibility, fatigue resistance, skid resistance, impermeability, and workability. Did you know that asphalt is America's most recycled product? 99% of asphalt is recycled and reused. Asphalt is also known as bitumen, macadam, blacktop, tarmac. There are nearly 2.3 million miles of paved roads in the United States, and over 90% is paved with asphalt. Asphalt is designed to last 20 to 25 years before it needs to be replaced. And asphalt condition drops only 40% during the first 75% of its life. This means that if you maintain your asphalt over the years, it'll last you a long time. So let's talk about asphalt service life. Asphalt pavements are typically designed to have a service life of 20 to 25 years. The service life of a pavement is the time at which significant maintenance becomes necessary. So here's a graph that shows asphalt service life and how it pertains to different types of maintenance activities as time goes on. You can see on the left we have pavement condition from good to poor, and along the bottom we have a timeline. And then the curve shows that asphalt declines as time goes on. These are typical maintenance activities highlighted, where in the early life of a pavement, preventative maintenance that's your opportunity for preventative maintenance. Then you go to minor rehab, which is an overlap with preservation, which is in the stippled area. Then it goes to major rehabs, then reconstruction, and then routine corrective maintenance. We're going to dive deeper into these topics, but I wanted to show how service life falls within these categories. So here's a chart that shows the optimum rehabilitation times to preserve quality and save money. As we mentioned, asphalt quality only drops 40% in the first 75% of its life. At the 75% point is the optimum time to rehab a pavement. The pavement condition is still good, but it has started to show some signs of failure. This is your chance to do some renovations and increase the pavement quality before the pavement starts to significantly decline in quality and higher level repairs are necessary. So if you did not do any rehabilitation at that point, then you're dealing with higher levels of repairs and the cost significantly goes up. Plus you're dealing with much worse pavements in worse condition during that time. So if you do your repairs at the optimum time, you'll save money and you'll have better quality pavements. And again, we're going to look at this later in our life cycle cost analysis. So pavement life cycle phases, those include material production, pavement design, construction, a use phase, maintenance and preservation phase, and then the end of life. So I'm going to go through each of these a little bit quicker on the material production, pavement design, construction, and use phase, because this is a talk about maintenance and preservation. But I wanted to provide this information as well on those categories because it provides some good background information when we start talking about maintenance and preservation. So let's start with material production. Asphalt is made in an asphalt plant. It's a mixture of 90 to 95% stone or aggregate and sand. It also consists of 5 to 10% bitumen or liquid petroleum binder and fillers, which are typically minerals. The aggregates carry the load. The binder or bitumen binds the pavement together, waterproofs the pavement, and can add stiffness to the mix. And the fillers perform the same function as aggregates. They resist the stresses imposed on the pavement. Asphalt mixture is a formula, and the optimum mixture combination is determined through years of research and development. Always use agency-approved mixes, DOT, FAA, UFC, depending on what the project is. Majority of the time, designers will use DOT for site projects. It is the most commonly used, and contractors are most familiar with it. And the reason for that also is for quality control and availability at the plant. Over to the right, we'll show a typical job mix formula for NCDOT pavement. And that's what the formula is based on, and we'll receive this job mix formula as a submittal, and we'll review it against the DOT spec. So pavement design. This is a typical pavement section where you have asphalt surface course, an asphalt intermediate course, base stone, and then a subgrade soils. The pavement thickness is determined by loading and soil bearing capacity. And the soil bearing capacity is determined from field testing. So pavement loading information comes from knowing the intended use, maximum vehicle loading, percent heavy vehicles, and traffic volume. Also consider future improvements. Is there a master plan? Are there possible changes in traffic circulation or loadings? This information comes from owner coordination and possibly a traffic study. So let's look at soil bearing capacity. Soil bearing capacity or strength is determined from field and lab work. Field work includes soil sampling and subgrade strength tests. Lab work includes soil classification, subgrade strength calculations, which are California bearing ratio, or strength of the soil relative to crushed stone, or resilience modulus, which is subgrade stiffness in PSI. This is a subgrade strength chart. So along the top, we're showing a CBR of greater than 10, which is classified as good. And the typical description of those materials are gravels, crushed stone, sandy soils. A CBR of 3 to 5 is considered as poor, and those materials include fine silty sands, clays, silts, and organic soils. So this graphic shows how subgrade strength CBR correlates to pavement thickness. You'll notice on the left, we have a CBR of good in green, and over to the right we have a CBR 3 to 6, which is poor. And this shows that with a good CBR, you'll have 3-inch less pavement thickness in soil excavation needed, which means you'll save some money. With a better soils, you're actually saving money and not having to construct as much. Asphalt pavement design also involves economics. You find the sweet spot of under design versus over design. You compare your pavement cost, total construction cost, and maintenance, repair, and reconstruction cost. You weigh the advantages and you consider the budget. Having good information up front allows you to be at the optimum. If there are several unknowns, for example, then the tendency is to slide the optimum to the right to account for some unforeseen situations, heavy vehicle circulation, possible changes in the future, etc. The key here is knowing your project. So let's slide over to construction. There are 3 responsibilities or categories of responsibilities in construction. Contractor's responsibilities, primary here, but we'll talk about the others too. So contractor's responsibilities is to construct within the construction documents, material testing and quality control, QC, and no shortcuts. The designer's responsibility is construction administration, CA, and making sure the contractor complies with the construction documents. An owner responsibility includes hiring a material testing firm to represent the design team and owner. This is for quality, construction quality assurance, QA. Let's talk about QC, QA, in-place material testing. A pavement is a structure. Test all layers as it's constructed. First, you do your subgrade tests, then you do your base stone tests, and then you do your asphalt tests. So let's look at subgrade tests. Subgrade tests include a Proctor test to get your density or percent compaction, and also do a proof roll inspection. Base stone tests include a nuclear densometer or sand cone method to get your density or percent compaction, An auger, or you could use a pick or something, but an auger is cleaner. You use that for your stone thickness. And proof roll inspection. An asphalt test requires core sampling to get your density, percent compaction, and test the asphalt thickness. A ballpark test is a nuke gauge. It's more theoretical than anything. Cannot be relied on for your asphalt. And that you can get general idea of density, percent compaction. Core tests always govern. A nuke gauge is used during rolling to get an idea how density is looking. Contractors will use it, or we can assist with quality assurance testing with a nuke gauge while they're under construction, but the core test is more reliable. And then these core holes, we recommend filling them with a non-shrink grout. It works a lot better than a cold pack asphalt, which can be very porous, and that's generally considered as a temporary patch. So interpreting asphalt test results. Compare results to the acceptable tolerances in the specifications. A density too low is bad, where too many air voids are in the pavement and allows water infiltration. This causes shrink swell cracking in cold weather. A density too high is also bad. This prevents binder expansion in hot weather, and the result is premature cracking. So what if asphalt tests fail? Warranties are not sufficient. Pavement failures won't appear for several years. Have in the specifications pay factors or DOT pay formula. This reduces the asphalt payment based on average test results, and will require a deduct change order at the end of the project. So these charts here show, the reduced pay factors. At the bottom, we have an NCDOT pay factor calculation, and it shows the not to exceed 2% plus or minus. If it is more than 2%, then it's a complete failure and they need to repave. And then there's a pay adjustment based on that formula. Over to the right is another way to present the information. There's a pay factor based on in-place density. So whatever your results are, above or below the requirement, then there's a pay reduction, and until you get to the rejection point. So notes about proof rolling. Proof rolling is not a compaction test. Compaction tests must also be done. Proof rolls just measure the deformation of the subgrade or stone, rutting and pumping. Even a properly compacted subgrade or stone base can fail proof roll, which is why we do proof rolls. So now we're going to talk about the usage phase. This is when the pavement is now under the control of the facility manager or owner. The key task to extend pavement life is to know what your pavement was designed for: maximum vehicle load, traffic volume, percent heavy vehicles, and service life. Periodically check for distresses. Keep up with maintenance and repairs. And follow an established maintenance and preservation plan. This saves money. So pavement distresses, what happened here? These are common types of pavement distresses. raveling, shoving, bleeding or flushing, drainage issues, potholes, transverse cracking, longitudinal cracking, bad patches, rutting, fatigue cracking, or otherwise known as alligator cracking, looks like alligator skin, or block cracking. Pavement deterioration is caused by many factors: structural failure, fatigue from loads, insufficient base stiffness or strength, insufficient subgrade stiffness or strength, climate, moisture, drainage problems, temperature change, freeze, thaw, sunlight, air, oxidation, or it could be mixed composition issues. So here's a pavement distress chart that comes from the Asphalt Institute Manual Series number 4, very well-referenced document. It shows the type of problems and its effect on the pavement. So you see the problems over there in blue on the left and what it causes to the right. So for example, let's look at what structural failures cause. So structural failures are caused alligator cracking, edge joint cracks, rutting, corrugations, depressions, potholes. And construction deficiencies will cause edge joint cracks, slippage cracks, rutting, corrugations, depressions, potholes, raveling, flushed asphalt, loss of cover aggregate. There's some similarities here. So if you look at construction, edge joint cracks, well, it also could be a structural failure. So that's, you kind of can use this chart to help decipher, the issues. Another way of looking at pavement distresses is possible problems due to environmental and geotechnical issues. So let's look at freeze-thaw, for example, and the problems it causes is fatigue cracking, rutting, bumps, depressions, potholes, and roughness. So by using the two charts, you can get a good feeling for what the issue is. So maintenance and preservation. Maintenance and repair categories, what's the difference? So we looked at this graph earlier. There's the categories of maintenance here: preventative maintenance, minor rehabs, major rehabs, reconstruction, routine and corrective maintenance. The traditional approach to maintenance is corrective maintenance. We're dealing with the worst first, waits for the distress to appear, it costs more, and pavement continues to deteriorate. A more recent approach is called preservation maintenance. It's proactive, it's performed based on triggers, it costs less, it's predictable, and it extends your pavement life. Corrective maintenance is reactive. It's kind of your fix what's broke. It does restore serviceability and reduces liability risk, all necessary. It typically includes pothole repairs, surface patching, and drainage repairs. Corrective maintenance is a necessary activity, but it cannot stand on its own. In the long run, doing corrective maintenance only is more costly and does not extend pavement life. So if you have a corrective maintenance program only, the overall pavement condition continues to worsen with time. So you could see some unit costs, and a little bit old, but they're still valid for the talk here. But the preservation cost, per square foot would be less in the early years. Then the pavement continues to decline and the cost goes up until you're dealing with a full reconstruction at the service life. Let's talk about asphalt preservation maintenance. It's proactive, it's less expensive, and it extends your pavement life. So we previously discussed corrective maintenance. That is a part of asphalt preservation. But this also includes what's called preventative maintenance and minor rehabilitations. So asphalt preservation maintenance, what a deal. Minimizes the life cycle cost of a pavement, extends the life of your pavement, and it can add structural strength and increase serviceability depending on the application. The catch is it requires analysis and proper timing. So let's look at the preventative maintenance treatments. Preventative maintenance treatments includes crack sealing and filling. Cracks are routed or not. Then the cracks are filled with hot poured asphalt sealant. Applying asphalt sealant or seal coats, it waterproofs the surface, it provides wear and chemical protection, and fills in small surface cracks. And preventative maintenance also includes full depth patches added to the above. This is for isolated failures and replaces failed section of asphalt and base stone and possibly some subsoil. So this is some various crack filling techniques that falls under preventative maintenance. I know it's hard to see here, but I'm going to go through a few of these. So this one here is called the flush fill approach. It's applied to non-routed cracks that are between 1/4 inch and 1/2 inch. You're just not doing anything to the crack other than trying to fill in those cracks with the asphalt sealant. This one is a standard reservoir and flush method. You use for cracks 1/4 inch or less, but then you route that crack and fill it flush with hot poured asphalt sealant. This one is called a deep recessed Band-Aid. Cracks are routed, filled, and capped with a Band-Aid, which is just overfilling to an extent on top of the pavement. And this type here is a shallow reservoir and flush method, where you do a shallow grinding and fill that grinded area flush with the asphalt surface. There's others in here. We're using backer rods, but that's typically not used as much. So types of asphalt sealants or seal coats. Seal coating or fog seal, more or less the same thing. It's an asphalt emulsion with additives such as rubber, and it's used for low-speed applications such as driveways and parking lots. A sand seal is a screened sand applied over asphalt emulsion and then it's rolled. This decreases glare, provides more skid resistance, it's thicker and more long-lasting, and it's better for driveways and parking lots, but it costs more. Slurry seal contains fine aggregates and asphalt emulsion and water, and this is better for heavily used roadways. You get your good friction, and it's more heavy duty for roads. All seal coats provide waterproofing, wear protection, and fill in smaller surface cracks. So let's look at minor rehabilitations. Minor rehabilitation treatments include thin overlays without milling, where you overlay the surface with a minimum thickness asphalt, and tack coat, the existing asphalt if necessary, and this improves serviceability. Milling if needed before step 1. Mill and fill cracks on the milled surface. This helps prevent reflective cracks. And then full depth patching added to the above steps for isolated failures. Milling, I want to briefly, is that you really need to know your pavement thickness before you start milling a pavement. You need to make sure you have enough pavement left before you go down and specify, just take 2 inches off the top and then come back with 2 inches, because you might have a half an inch left and it's just going to be worthless. So that's a word of caution on milling. So what if your pavement looks like this? It's too late for preventative maintenance treatment. Requires major rehabilitation or reconstruction. This is what we call our end-of-life phase. Major pavement rehabilitations typically include treatments like a heavier mill and fill, where you remove all the asphalt and then add a thick design structural overlay, or correcting surface deformation, where you're milling and adding a leveling course and then adding a thick design structural overlay, and correcting major drainage issues in addition to the above. Major rehab applies when the surface will no longer benefit from preventative maintenance. It includes all activities short of replacing the entire pavement section. Pavement reconstruction. This applies when there is a general failure in the pavement. Option 1, full depth base reclamation with a thick design structural overlay. And then option 2 is remove and replace the entire pavement section. I'm not going to go into that. I think that option 2 is more self-explanatory. We're removing all the pavement and stone and coming back with new. But pavement, full depth reclamation, this is when you construct a base out of the existing surface. You pulverize the surface, typically 8 to 10 inches deep. All your stone and your asphalt is getting pulverized in place, and it's grinding up soil as well. It's all part of the design. You add a Portland cement and water to it, you let it set, and then you overlay this with asphalt. The benefits of full depth reclamation is that it creates a very strong base in the field. It's called a super base. It bridges poor soils. Typically, no undercut is needed. And it's typically less expensive than asphalt removal and replacement from 2 to 3 acres up. Note that FDR may not work for every site, so you need to check your constraints. FDR also raises surface elevations. The addition of cement adds approximately 1 inch of elevation per 12 inches of pulverized material. Existing asphalt can be removed and recycled first. If not, account for its elevation when you come up with the grades for the new asphalt surface. It's worth noting that when the material is pulverized in place, it can be graded. So if you do have curb and gutters and you're concerned about raising elevations, this may be a good opportunity to change your slopes with a little bit of grading. You got to be careful of not overgrading, but that can be done. There's also ways of grinding the material and placing it to the side and then using it before you add the water to it and also create some slope. Again, this is a very, it can be very cost effective and creates a very strong base. So let's talk about the effectiveness of full depth reclamation. At the bottom, you can see the yellow bar chart shows that yellow represents full depth reclamation, and then the orange represents a new base. So the number of trucks up at the top, considerably less for full depth reclamation. New roadway material in tons, considerably less. Material landfilled, 0 for full depth reclamation. It's, you know, very environmentally friendly and can be considered a green process. And diesel fuel consumption is much lower. A little more field work to get the prep work together. That's why there's that 2 to 3 acre, you know, break-even point. But from there, the cost is considerably less. In design projects, we will have an alternate for one or the other, just to know what our pricing differences are. So what type of repair should we do? It's all about condition and timing. If the pavement is structurally stable with isolated failures, preventative maintenance and minor rehabilitation. When pavement is in a general failure, major rehabilitation or pavement reconstruction. And then corrective maintenance needs to happen all the time, anytime it's needed. So it's time for a maintenance and repair plan, pavement evaluations. Why are maintenance plans important? Planned maintenance saves money. They provide control and predictability. Planned maintenance keeps your pavements looking great. They provide cost-effective solutions based on engineering analysis. They contain repair options and phased approaches, work within your budget. They provide credibility when requesting funding. Pavements will be safer and last longer. So here are the typical phases of a pavement evaluation. Phase 1 is when you do a condition assessment and problem identification. You collect data, you evaluate the data, and you identify constraints. Phase 2 is when you assess potential solutions. You establish feasible solutions, develop preliminary designs, and phase 3 is a selection of preferred solutions, cost analysis, identify any non-monetary solutions, preferred rehabilitation alternatives, and detailed design. So step 1, coordinate with the owner. The owner's, that's when you find out what your owner's goals are, their priorities, their preferred project phasing, their budget, short-term or long-term, past site usage, vehicle loadings, future plans, any master plans available, traffic circulation patterns, and obtain their historical records, record drawings, construction submittals, job mix formula, stone, geotechnical reports, material testing reports. Was any asphalt testing done at all during construction? Utility installs, find out where your utilities are, your constraints, possible depths. And to just obtain any maintenance records. This is all the information to build a background for this evaluation. And walk the site with the owner, very important. Ask questions, learn from their facility knowledge. Step 2 is site surveys. This is when the engineer does a detailed survey of the site, measure the pavement distress areas, mark pavement core locations if needed, take photos, check for ADA compliance, bring a laser level, check for drainage issues, utility conflicts, note traffic circulation patterns, check for constraints, construction constraints, pedestrian traffic, etc. Be very thorough. So when you do a pavement evaluation, this is the ideal time to check for ADA compliance, especially if there's considering repairs. You don't want to build back something that was wrong to begin with. So this way you look at your parking requirements for slopes, etc., detectable warning strips, surface materials, ramps, extensions, accessible routes, and all your directional and identification signage, like ADA signs, etc. I'm going to look at a few different site survey remediation guides. These could be brought in the field and used in combination. This one here is an asphalt pavement rating form. It's used with a scale, which is down here at the bottom. And the scale has a condition rating and then the maintenance action above the top. The pros of this form is it provides a quick feel for the extent of defects. Cons is solution on the scale are too basic. You need more information, patching, crack filling, etc. And it doesn't address the reason for the failures. The way the chart works is a rating of 0 means there's no defect, and then you kind of just look at, your different defects such as transverse cracking, longitudinal alligator cracks. And then you put, just throw a number in there, okay, well, it looks like a 5, looks like a 6, whatever. And then you total up. So I just put some numbers in here, came up to 35, put it down here, 100 minus 35 gives you a 65. And then you see where it falls on the chart. So in this case, it shows that an overlay is needed. But I don't really use this much, but it does give an idea of the extent of the damage overall. So here's another site survey remediation guide. This is also from the Asphalt Institute's MS4. We looked at this portion earlier. It was spread out horizontally, but it's the same chart where we looked at pavement distresses and possible causes. But on this side, it shows possible maintenance solutions based on severity. So an example here is alligator cracking. You see that the possible cause is a structural failure. But then you look at, you go across, and based on the severity of it, you can maybe use the guide number 1, is it shows that a maintenance for just general maintenance, patching and routine maintenance, that applies. Surface treatment would apply, or a slurry seal. If your extent of your deterioration is worse, then you're in the rehabilitation area, and that means a structural overlay. And then if it's really bad, then recycled materials, which is that full depth reclamation that I mentioned, and or just new materials, remove and replace. This has more description down the bottom, so it's helps to guide you through which categories apply. And then the third remediation guide is like I call it a flow chart, but it's for preventative maintenance, and it's good for that, for sure. The cons are the severity level can be deceiving, so need to know when it's too late for a preventative maintenance treatment, and it doesn't cover rehabilitation or reconstruction. But again, you look at the extent of your cracking, say you're at a moderate, cracking and the surface wear is low, so then, okay, your recommended treatment, here's a crack treatment and surface treatment. Again, it's pretty basic, but it's something that can help. So digging deeper, material sampling and testing if necessary. This is when you do pavement cores. You find your existing asphalt thickness, determine milling options, get your existing stone thickness, and get a feel for reflective cracking. Is this a crack that's fully through? And in the picture on the right, yeah, that's fully through, but there may be some areas that may not be, depending on the thickness of that surface. And then subgrade soil tests. You get your soil composition, moisture content, Atterberg, and strength tests through you get a DCP in the field and you convert it to a CBR and do some calculations. And then this is also the data you gather for a full depth reclamation design. You need to know what material you have in order to know what to design for. And step 3 is prepare mapping. This is kind of like a low-level base map for analysis. Use the following: that historic data we collected earlier, record CAD files, record drawings. You can use aerials, you digitize your aerials. It's just to get yourself a map to start to work from. Local GIS line work, LiDAR topography, and field survey if needed. Add to the base map any boring locations, areas of pavement issues, some of those measurements you took, and then the photo locations. And during the assessment, circle back to the owner and facility manager throughout. It's important to coordinate, provide updates, and ask more questions. So, step 4, evaluate data, develop solution options. Solution options will include all the categories we discussed. There are corrective maintenance options, preventative maintenance options, minor or major rehabilitation options, and reconstruction options. Look at phasing options, base, bid, and alternates. Identify project-by-project solutions. Note pros and cons of each phase. Consider cost escalation and worsening. And provide an opinion of probable construction cost. This is a cost-benefit analysis. So let's talk about the cost-benefit analysis. This chart we saw earlier, where you're looking at your optimum repair time, is around 75% of the service life. Here's a project example with a cost-benefit analysis with some maintenance options. Here in yellow, you see the 75% point, and over here in orange, you see the 100% life expectancy for that pavement. Over at the left side in blue, we have new parking lot A. It's 10,000 square yards, about 2 acres. You put in your service life, and then you have years. So here we're at year 0 because it's a new pavement. And then over horizontally to the right, you got years. So we start with 2 years, 4, 6, 8, et cetera, till you get to your 20. And then you have a cost inflation of 5% per year. That may change as years go on, but that's what we know today. And then every 2 years you're adding, it's 10% for 2 years. And you go across there, and then over here on the left, you got maintenance options and 2020 unit costs. So these are some options here, different categories for those options, and then some unit costs. So let's look at the first one. So option 1 is your no maintenance until minor rehab option. In this case, absolutely nothing is done to the pavement until we got to replace it. So today that would cost $500,000. But at year 20, you're looking at $1 million. Okay, so option 2, corrective maintenance until there's a general failure. So in this case, you're doing everything right. You do your seal coating. In year 6, you might have to do some shallow patching or pothole repairs. Year 10, still seal coating, potholes, but then you got some full depth patching, all good stuff. And you get to year 20, and that's the point where something serious needs to happen. So that's a point where you're looking at a minor or a major rehabilitation or replace the surface. The total cost is less than the first option. And then preventative maintenance. So this is very similar to option 2, but in this case, the pavement was in good condition at year 14. So now you're only dealing with a minor rehabilitation, thin overlay, like 1.5 inches. So you do that, and then you add up your costs. You don't have to do your seal coating. You just have to do seal coating at 2 years later. No patching, no pothole repairs. And at year 20, you're at $425,000. So considerably less money. So comparing the 3, $1 million, $750,000, or $425,000. In the notes section is also important. So we talk about the pavement condition at year 20. So for option 1, it not only costs the most, but the pavement is in poor condition during its life. Expect very poor pavements from year 14 to 20, and it's most expensive in the long run. Option 2 is pavement is in better shape over 20 years. It costs less, and the cost is spread out over time. And then option 3 is the service life was extended to year 26. Pavement is in the best shape over the 20 years compared to the other 2. It's the least expensive, and cost is also spread out over time. The cost difference between options 2 and 3 is due to timing of maintenance. Option 3 has the best 20-year asphalt performance, cost the least, and pavement life was extended another 6 years. So we're at step 5 of the final report. In that, we wrap up all the information that we've gathered and learned and coordinated on. And that's when you prepare a narrative, get all your historical data and research together, put all your site surveys together, your photo log, your mapping, you identify your feasible solutions, have your construction cost estimates in there, cost-benefit analysis, preliminary designs if applicable, and pavement maintenance schedule options are identified. And then detailed design is your next steps, where you would also do a, next step also includes providing a custom pavement maintenance schedule. Provide maintenance guidelines for the pavements. Provide optimum schedule for pavement preservation to save money and extend pavement life. And attach backup information. This is going to be your resource, kind of like an O&M guide, where you get your pavement design parameters in there. You have your pavement design and your specification, your pavement detail, your geotech report, your in-place testing results, job mix formula, and service life. So everything you need to know about that pavement is in there, including all the guidelines for that specific treatment that was done. And That's about what I got. So I appreciate your time, everybody. Ran a little long, but I hope it was informative to everybody.
Thanks, Frank. It's great information. I do have a quick question for you. For parking lots or something similar, is there an advantage to installing each subsequent asphalt layer in the perpendicular direction to the underlying layer? For example, is it like the base layer running north and south, and the surface layer running east and west?
Not necessarily. It is important to overlap your joints. So you'll notice that pavers will go in the longest direction just for ease of construction. There is no benefit to one versus the other. In fact, I do think that it may be better to go longer because you're not running over as many seams. So, you know, I would have to say longitudinally would be the better approach for that. But in your layering, if you have two lifts of 1.5 inch, for example, you know, you would want to make sure that your seams don't line up. That's important as well.
Okay. While we're waiting for some other questions to pop in here, I just wanted to remind everybody that all certificates of completion will be sent out via email post presentation. So be on the lookout for that. And we do have other webinars that we are hosting, and you can register for them on our website at www.timmons.com. So if anybody doesn't have any other questions, I think you did a good job, Frank, and you must have answered everyone's questions. So good job on that. Liz says, thanks, Frank. This is a very informative presentation. And so thank you for your time and your information. And thank you for your attendees for hopping on here today. We appreciate you, and hope you have a great rest of the week. Thanks, Frank. Everyone have a great rest of the day. Bye.
Thanks, everyone. Talk to you later.